Hello everyone, hope you are doing well. Today we are solving our next problem, which is given an array which contain of 0, 1 and 2. We have to sort the array without using any sorting algorithm. Let's move to the problem statement. In this problem we are given an array consisting of 0, 1, 2. We have to sort the array in ascending order. Suppose the array is this, then the output is this. Let's move to our whiteboard to understand the problem more clearly. And suppose we are given an array like this: 0, 1, 2, 0 and 1. We have to sort the array, that means in ascending order. That means 0 comes first, and then 1, and then 1, and then 2. We have to return the array in this order. What could be the first approach that we can think of? If we just sort the array by using any sorting method or boolean method. Suppose now we sort the array using boolean method. Sort array dot begin, array dot end. Let's compile it. It takes two time. It passes the example test cases. Let's submit it up. Yes, it works perfectly. Now move to our next approach. So suppose the array is this: 1, 0, 1, 0, 2, 0 and 1. uh, we have given only three type of element. One is 0, one is 1 and one is 2. If we store the count of every element and write element in ascending orders, that means first we write all the occurrences of 0, then we write all the occurrences of 1, then we write all the occurrences of 2, then the arrays also become sorted. So what is here? We write the occurrence of 0. 1 times 0 occurs 2 times and 3 times, so we write 3, count 3. Now check for 1. So here 1 times 1 occurs 2 times, 3 times, so the occurrence of 1 is 3. Now check for the occurrence of 2. So 2 is occurring only one time, so we write 1. So because 0 occurring 3 times, so we write in the starting 3 index with 0, 0, 0 and 0. And then we check for 1, 1 occurring 3 times, so we write 3 times 1 over here. Wait a minute, I will clear it. Write 3 times 1 of it. And 2 occurs one time, so we write 1 times 2. So now you can see the array will be sorted. Let's first implement it, then comes the dry run of this code. So what we can do, let's clear it up. We create three variables: int 0 is what 0, in 1 initialize with 0 and 2 initialize with 0. Take a loop, I is what 0, I should less than array dot size, I should be incremented. If arr of I re double equals to 0, so we increase the count of 0 by 1. If arr of I double equals to 1, increase the count of 1 by 1. If arr of I double equals to 2, so increase the count of 2 by 1. So first we write all the occurrences of 1. idx are you 0, while 0 count are you greater than 0, we write arr of idx, could you please write 0. So we increase the count of 0 by 1, decrease the count of 0 by 1 and increase the index by 1. Now we will write all the occurrences of 1, while 1 are you greater than 0. So for arr of I of arr of index, can you put 1, and 1 count should be decremented and idx should be incremented. And now we write 2 count. If 2 are you greater than 0, so arr of idx equals to 2 and 2 should be decremented and idx should be incremented. Let's compile it. Yes, this passes the example test cases. Let's submit it up. Okay, more clearly, let's take a screenshot of it to whiteboard, paste it over here. Let's make it some small kind of stuff. Okay, suppose we are given an array like this: 0, 1, 0, 2, 0, 1 and 0. Okay, so using this line we initialize three variable with 0. So initialize 0 with 0, 1 with 0 and 2 with 0. Okay, okay, take a loop from 0 to ARR size. So let's take a pointer over here. See, now check ARR of I equals to 0. So yes, we increase the count of 0 by 1. So it will become 1. Now we check ARR of I equals to 1. No. ARR of I equals to 2. No. Now all the conditions check. So we increment the pointer by 1. Okay. Now ARR of I double equals to 0. No. ARR of I double equals to 1. Yes. So increment the count of 1 by 1. So it will become 1. Now we check ARR of I double equals to 2. No. All the conditions are checked. So we increment the counter by 1. So counter will reach over here. Now again check ARR of I is 0. Yes. So increment the count of 0 by 1. It will become 2. Check for 1, not match. Check for 2, not match. So increment the counter by 1. Wait a minute. Now we check ARR of I equals to 0, condition false. ARR of I equals to 1, condition false. I equals to 2, condition true. So we write increment the counter of 2 by 1. So it will become 1. Now we increment the pointer one step ahead. So again check ARR of I equals to 0. Yes. So we increment the counter by 1. It will become 3. ARR of I equals to 1. No, it is 0. ARR of I equals to 2. No. So we do nothing. Increment the pointer by 1. So it will reach over here. Now again check ARR of I equals to 0. No, it's 1. ARR of I equals to 1. Yes, it is 1. So we increment the counter of 1 by 1. So it will become 2. Now we check ARR of I equals to 2. Condition false. Increment the pointer by 1. So it will reach over here. So ARR of I equals to 0. Condition true. So we increment the counter by 1. It will become 4. ARR of I equals to 1, condition false. ARR of I equals to 2, condition false. So we increment the pointer by 1. So it will reach end of the loop. Now we take an index variable which is pointing to 0. So let's say this index, it is pointing idx. Wait a minute. So until our 0 count is greater than 0, we write ARR of idx to 0. So our count is 4, so we write here 0, increment index by 1, and decrement 0, so it will become, wait a minute, it will become 3. So 0 are you greater than 0, condition true, index where we write 0, so here we write 0, decrement 0 by 1, so it will become 2, increment index by 1, so it will, wait a minute, it will comes over here. So again 0 are you greater than 0, condition true. So we put ARR of idx to 0, so we write 0 over here, decrement 0 by 1, so it will become 1, increment index by 1, so it will reach over here. Now again check 0 are you greater than 0, yes, 1 is greater than 0, so we write ARR of idx to 0, we write 0 over here, decrement the counter of 0, so it will become 0, increment the index by 1, so it will reach over here. Now 0 are you greater than 0, so 0 is what, 0 is not greater than 0, so while loop will be terminated. Now we move to our once loop, in which we check 1 are you greater than 0, yes, greater than 0, so we write ARR of idx to 1. So here we write 1, decrement the count of 1 by 1, so it will become 1, increment the index by 1, so it reaches over here. Now again check 1 are you greater than 0, yes, 1 is greater than 0, ARR of idx are equals to 1, put 1 over here, decrement the ones count, so it will become 0, increment the index by 1, so it will reach over here. Now 1 are you greater than 0, no, it is not greater than 0, instead it is equals to 0. We turn our while loop will terminate. Now we move to our 2's loop, and we check 2 are you greater than 0, yes, 1 is greater than 0, then we put ARR of idx to 2, so we write 2 over here and decrement the count of 2 by 1, so it will become 0, and increment the index by 1, so it will reach the end of the loop. So we can clearly see that our array will become shorted. So let's understand the time complexity of this loop. So our first for loop is running from 0 to ARR.size. So the time complexity of this is order of n, where n is the size of the array. So 0, 1 and 2, this will also move, all these three loops also moves n times. So the overall time complexity of these three loops will be order of n. So the total time complexity of this approach will be order of 2n, which is apparently order of n. Hope you are understanding this approach clearly. Let's move to our next approach. This is a very famous approach which is called a Dutch national flag algorithm. In this algorithm, suppose we are given an array like this: 0, 1, 0, 1, 2, 0, 2, 1, and 0. In this algorithm, we take three pointers: one is low, one is mid, and one is high. Low is take care about 0, mid is take care about 1, and high is take care about 2. Initially low is initialized with 0th index, mid also initialized with 0th index, and high initialized with array dot size minus 1. Dot size minus 1, which is the last index of element. So we take three pointer: one is at low index, low is pointing over here, mid is pointing over here, and high is pointing over here. In this algorithm, we take a while loop until mid is lesser than or equals to high. So what we can do? Low says all the element before where I am pointing, all the element before me are equals to 0, and high says all the element after me is equals to 2. So let's say what this algorithm works. So the algorithm moves in 3 steps. 3 if condition checkation. If ARR of I, ARR of mid, if it is double equals to 0, then we swap ARR of mid with ARR of left, ARR of low. Increase low by 1. If ARR of mid, else if are you double equals to 1, so we increase mid by 1, do nothing because mid is take care about our 1. So else if ARR of mid are you double equals to 2, so swap ARR of mid with ARR of high and decrement high by 1 minus. So here what's happened? Here we are at mid at the 0th index. We check, hey mid, are you equals to 0? It says yes. So we swap ARR of low and ARR of mid. So swap after swapping ARR of 0 with ARR of 0, there is no change because the same element is swapping. So what do the next? Increment low by 1. Increment low, wait a minute. Increment low by 1 and mid by 1. Again check ARR of mid, are you equals to 0? No. ARR of mid, are you equals to 1? So increment mid by 1. Wait a minute. So increment mid by 1. Now check ARR of mid, are you equals to 0? Yes. So swap ARR of low with ARR of mid. So what happened? Here 0 is coming and here 1 is coming. So increment mid by 1, increment low by 1. You can see low says that all the element where I am pointing before that me all should be equals to 0. All should be equals to 0. So mid is 1, do nothing, increment the pointer by 1. So mid will reach over here. Let's clear some stuff. This is our mid. So now 2 is encountered. So ARR of mid equals to swap ARR of mid with ARR of high. So 0 is come over here and 2 is come over here. So what we can do? We can decrement high by 1. You can clearly see that high says all the element after me equals to 2. So again we check for mid, ARR of mid, are you equals to 0? Swap ARR of mid with ARR of low. So here 0 is coming and here 1 is coming. So again we move low by 1. Wait a minute, what's happened? So again we move low by 1 and our mid by 1. Again 0 encounters. What is this nonsense? Let's clear it out, then again we understand. Delete it. So our low is pointing over here. Let's clear it. And our mid is pointing over here. So our mid is equals to 0. We swap ARR of mid with ARR of low. So 0 is come over here and 1 is come over here. We increment both low by 1 and our mid by 1. So to encounter, so we swap ARR of mid with ARR of high. So what happened? 1 is come over here, 2 is come over here. High is decremented now. High is reached with this. So high and mid pointing to the same index. We check AR of mid equals to 0. So we increment mid by 1. So mid is pointing over here. So you can clearly see that the array is now become shorted. Let's move to the implementation part of it. After that we will dry run it. So it will clear. So what we can do over here, we take 3 pointer, one is low which is pointing to 0, one is mid which is pointing to 0, one is high which is pointing to array dot size minus 1, while mid are you lesser than equals to high. So we check 3 conditions. If ARR of mid, if u equals to 0, then we swap ARR of mid with ARR of low. Mid should be incremented and low should be incremented. Else if ARR of mid RE double equals to 1, simply increment the mid by 1. Else if ARR of mid RE double equals to 2, then swap ARR of mid with ARR of high and decrement the high by 1. Let's compile it. It passes the example test cases. Let's submit it up. It works perfectly. Let's take the screenshot of it and move to whiteboard to dry run this code. So paste it over here. Let's do some small kind of stuff and make some space. Okay, I think it is properly visible to you. So let's suppose you are given an array like this: 0, 1, 2, 0, 1. Okay, no issue. You have 3 pointer: low, mid and high. You point low at here, mid is also over here, and a high is here. So we take while loop until mid is lesser than equals to high. Mid, let's write the indexing 0, 1, 2, 3, 4. So 0, are you lesser than equals to 4? Condition true. We move inside the loop. ARR of mid are equals to 0? Yes. So we swap ARR of mid with ARR of low because both are pointing to the same index. Nothing will change. So we increment mid by 1. So after incrementing mid by 1, so after incrementing mid by 1, mid our reaches over here and increment low by 1. So after incrementing low by 1, low will reach over here. So again we move to the top because all the else condition will not be executed. You clearly know it. Mid is pointing to 1 and high is pointing to 4. So 1 is lesser than equals to 4. Condition true. Check ARR of mid equals to 0. But now our mid pointing to 1. So condition false. We check the next condition. ARR of mid I double equals to 1. Condition true. So what we can do, we will do increment mid by 1. So mid will reach over here. Now check ARR of mid are you less than equals to ARR of high? Condition true. So ARR of mid are you equals to 0? No, it's 2. ARR of mid are you equals to 1? Condition false. Again check ARR of mid are equals to 2? Condition true. So we swap ARR of mid with ARR of high. So what will happen? 1 comes over here and 2 comes over here. Okay. Decrement the high pointer by 1. So high will reach over here. So again we check ARR of mid are you lesser than equals to high? Mid point to 2 and high point to 3. So 2 is lesser than equals to 3. Condition true. Check ARR of mid are you equals to 0? No. Then check ARR of mid are you double equals to 1? True. So we increment mid by 1. So mid will reach out to here. Now again we check AR of mid, are you lesser than equals to high? Condition true, because both are pointing to the same index. AR of mid, are you equals to 0? Condition true. So swap AR of mid with AR of low. So 0 will come here and 1 will come here. Next step is to increment mid by 1. So mid will pointing to here, increment low by 1. So low will move here. So now we again check the condition. Mid, are you lesser than equals to high? Condition false, because mid is pointing to 4, which is greater than the high. So you can clearly see that the array become the shorted. The time complexity of this approach is order of n, because we are taking only single loop which will iterate every element only once time. So if you find my video helpful, then don't forget to like, share and subscribe. If you face any doubt in this algorithm, you can ask me in the comment section. I will definitely help you. Thank you.